All right, welcome everyone. Welcome to our webinar. My name's Ian Scarrett. I'm the head of marketing at HiveMQ, and we're thrilled to have everyone join us. Our webinar for this month is kind of what we're calling Back to Basics, an introduction to MQTT. A lot of people really express interest in this topic. I guess there's a lot of people out there still learning about MQTT and trying to understand how to use it. So we're thrilled to have everyone join us. Also, very pleasant to introduce our speaker today. Mary Grygleski is actually new to HiveMQ. She joined us from IBM, and she's going to be our senior developer advocate at HiveMQ. So Mary's got a wealth of experience of doing presentations. She's very well known in the Java developer community. She's a Java champion. And so we're thrilled to have Mary join us. Just some housekeeping for us. The session will be recorded. So we will be sending out a recording and the slides to everyone afterwards. If you have a question, please use the Q&A pod at the bottom. Please don't put questions in the chat. It's much easier for us to follow along with the Q&A. We will have about a Q&A session at the end, so we'll hopefully get to people's questions. Yeah, so I think those are the major things. And for now, I'm going to turn it over to Mary and welcome Mary, and we're very much looking forward to listening to your webinar. So Mary, take it away from here.
Thank you so much, Ian. Thank you so much for the introduction. I really appreciate that. And welcome everyone. And I realize that when I'm looking at the chat, it's really amazing. You are all from everywhere in the world from different time zones. So thank you so much. I really appreciate this. Will be my first webinar at HiveMQ. And as Ian said, I just joined HiveMQ just 2 weeks, not even a month yet at this point. So it's been really exciting, so much to learn, so much to share. And so that's where I am. And so we're all on this learning journey together. So thank you. Let me kind of go start my slide now. Okay, so today's topic is back to basics. So this is really about an introduction to MQTT. And as such too, we're trying to squeeze in a lot of information. So bear with me. If you have questions, please do enter them onto the dialogue here. There's a Q&A. There's also like chat dialogue, as Ian also pointed out. So without further ado, just a quick introduction about myself. And I think Ian already said most of the stuff, so I'll just highlight, I'm a Java champion, I'm president, and also executive board member of the Chicago Java Users Group. And also I'm a really active community builder too. So I want to invite you to join me there too. I also run a Twitch live coding streams. Actually, this afternoon I'll be online again. And this is the various ways of how you can get a hold of me. Okay, so today's agenda. First, we'll talk a bit about the IoT stack, and then give you a bit of a history about what is MQTT and what is it about, some kind of like high level view, some key features. We'll be talking about it. And then we'll get into a bit of what would be the use cases for MQTT, and then some alternative protocols for IoT and integrations with some other frameworks. And then we'll summarize. And then after that, we'll do a quick demo to show you some of the features that especially HiveMQ has in this MQTT space. Okay, so first, from 30,000 feet, right, the big picture, the IoT stack. I think too is that when we bring up the word IoT these days, everybody is like, wow, this fancy thing. And then it also means different things to different levels of concern. Just like the OSI, the networking layer, if you're familiar with that, right? There are many layers. So the IoT itself too also has like, different layers of concern, so to speak, in this space. So let's kind of take a look, right? First of all, when I got into this IoT space too, I have folks that are actually more from, the consumer side. They're like, oh, wearables and, your home alarm system, something like that. And then, of course, then if you get into a business, there's enterprise, there are like business operations, all of these, they can be making use of IoT technology. And then also too is that the big places where MQTT especially can kind of really, that we can draw on this strength is really on the industrial level, which is like manufacturing, all of these things that are, generating so much, use for us in today's world. Okay, so that's more on the solution side. And then we also have folks that are actually from the AI, from the machine learning, doing different things with data that's kind of coming from IoT space, and analytics, right? Services, reports, all of these things. But what actually, IoT, when we talk about it, if we kind of look at it as layers of things, we start with all the devices, right? And like say smart devices, sensors, actuators, embedded devices, and you can build things, and that's the beauty of it. You can actually take things and start building it on your own, Raspberry Pi and Arduino and things like that. You can make leverage on IoT messaging and the beauty of using MQTT too. And then in order to do that, then we have to rely on, obviously, if you look at building blocks and the communication protocols layer. So I wanted to kind of show you, right? That's where MQTT fit. Although this particular layer in here, I'm kind of abstracting the whole thing. These communication protocols itself have also many layers within itself. But here too, I'm kind of grouping, MQTT is more on an application level, right? Networking kind of thing. And then there are also other protocols that are, helping with IoT messaging. And then there's also IPv4 and some things I want to point out too. For example, like in this small device, especially communication, there's also 6LoWPAN, which is the low power wireless thing where you can also leverage on IoT messaging, all of these Bluetooth, GSM, all of these things. And then there's also the core platform that kind of is built on top of the communication protocol, which is the IoT messaging middleware. And that's where HiveMQ is the product offerings that we have, is to help you essentially too, is enabling you to do all of the things that's kind of on top of the, in this stack here. So yeah, so with that understanding, let's get busy and get into understanding what MQTT is. So what is MQTT? It stands for let's see, it stands for message queuing telemetry transport. I'm sorry, just a little speaking too fast. So it is a standard binary protocol that's actually supporting the publish subscribe messaging protocol. It's designed for fast and reliable data transport between devices, especially under very constrained conditions. And so that's kind of like the key thing, is that, we have many other protocols out there, many pops up, but the MQTT is targeting for operating environments that are, very constrained with very little resources. And that's where the strength lies for MQTT. And as you can see, it is built on top of TCP/IP, in the networking layer perspective. And so as such too, it's really ideal for the Internet of Things, because you can have many things, like I was pointing out, devices that are smart devices, sensors. All these, they are operating on, under very constrained kind of situation, high latency networking environment, low bandwidth, and that type of stuff. So, and as you can see here too, this is just a diagram to kind of illustrate, right? So the core of this MQTT is a protocol, but there's also actually the broker that is making, like, essentially, think of the broker as like a post office, right? So think of it like that. You want to send a message, you want to mail a letter. You don't go and directly bring the letter to your receiver. You go through the post office, right? So think of it like the broker is like the post office. You do things, you go through the post office, they would deliver it for you. And instead of using address, right, like IP address, is actually using topic to kind of do that too. It almost seems like you're writing, the address of somebody, well, kind of a mailing address like that. So then the broker, then in this case, like the postmaster, will know where to deliver to all the destination, and whoever needs it. Actually, in this case, not quite like a post office. You don't really subscribe, you don't really like receive it without, doing anything. You actually have to subscribe to what you're interested in. So in that sense, it's not exactly quite like a post office, but we illustrated using a post office to kind of describe this. So, and over here too, in this example, we're talking about a speed. For example, you need to publish the speed and basically publish it to the broker. So whoever is interested, in this case, a mobile device, a backend server is interested in that, you subscribe to the topic that actually when the data arrives, then you will receive it eventually like that. So a brief history too about MQTT. So MQTT was invented in 1999 by Andy Stanford Clark, an IBMer, and then also with his partner, Arlen Nipper. And Arlen actually was then working for Arcom, which is now ServiceLink. And they were actually doing some consulting projects with oil pipelines. Some of the data that they need to gather from these oil pipelines they were like connecting with satellite. And they realized that it was actually hard to do at that time. There was no specific protocol. And they basically invented the MQTT to address the needs because it was a very limited kind of operating environment. So you can only afford like minimal battery loss, and there was only like minimal bandwidth. So they kind of invented that. So it's a bit of history. So if we kind of take a look at the timeline, 1999, essentially too, it's basically MQTT got invented. And at that time, it actually wasn't quite the standard yet. It was just like, think of more like a proprietary type of protocol to address oil pipeline and monitoring. And then in 2010, it's basically too, then there were increasing interest in it because it really is a very versatile type of protocol, right? That's simplistic too, and it's not way too complicated like some of the other things. So then there were increasing amount of interest in it. And then there was a lot of development. So in 2010, MQTT 3.1 was opened up as a royalty-free protocol. Then in 2012, basically Mosquito 1.0 got released. And then HiveMQ at that time was also forming and also then worked on this protocol. And in 2013, that's when version 1.3 got released for HiveMQ. And then in 2013, not long after HiveMQ 1.3, it was the OASIS, which is the Open Standard Committee consortium, was kind of technical committee was formed for MQTT to govern this protocol. And in 2014, and that's when MQTT 3.1.1 is officially released. And that's the version that's still being widely used in today's. And then in 2018, that's when MQTT 5 officially got released. And that's actually contained a lot more robust, think of it more like, okay, we got the basic now, and now we're going to go into another kind of phase of this protocol that can support a lot more things, and such as like getting it ready for cloud native, some of the features that I will be discussing about. It's basically making it a lot more usable in today's demanding world. And then in 2018, that's when HiveMQ 4 became started supporting MQTT 5 as well. So that's a kind of a quick timeline. And as far as the MQTT technical committee is concerned, because again, it's an open standard, kind of open to everybody's contribution, from the community. So there's a committee too. So as you can see, there are 9 primary kind of companies that are obligatory having need for members to join. So over here too, as you can see, HiveMQ is one of the key member of this committee. And then we also have our CEO, Christian Getz, and also our CTO, Dominic Obermeyer. They are both leaders in the technical committee too. Okay, so now get into a bit more about MQTT now. So what is MQTT? So a bit of an overview. It is actually an IoT messaging protocol, again, making use of the pub-sub model, right, of operation too. And then there are essentially 3 quality of service levels. So this is actually a key feature of MQTT because it helps to guarantee your message delivery, or at least it kind of makes sure that the client would have control about the kind of message that it needs to be carrying and needs to kind of make it to its destination too. So that's kind of key feature. And then there's also this feature called retained messages. And also the beauty of MQTT is that there's the statefulness and persistent sessions that are being supported too by this protocol. So therefore a broker will have to implement these features too. And then it's actually, the protocol itself is very lightweight. It's binary, essentially binary protocol, and with minimum overhead. So let's now get into taking a look at the MQTT 3.1.1 features. First of all, I wanted to talk too about the pub-sub kind of operating kind of a model, right? So as such, right, publish, subscribe. Again, I kind of brought up already the broker and that being like the crux of kind of enabling messages to flow, because it's the central, think of it like the center stage, the post office in there. So as you can see too, any kind of MQTT client, you can be like publishing messages. In other words, it's like I produce all the messages. And so whoever is interested in it, I can subscribe to it too. So the MQTT client is referring to both the producer and the consumer, or the publisher and the subscriber. And in order to kind of communicate, it will be sending commands over to the broker. So as you can see over here, it's just a quick diagram to illustrate, right? The basic commands are like connect and then subscribe and publish. So every time if you connect, do a connect from your client to the broker, then broker will have to acknowledge it. So then basically you're seeing that there's also a connect, like acknowledge, and then you do a subscribe from the client and broker will acknowledge it. And then, and also to publish, and you'll be receiving a publish acknowledge from the broker. That way you guarantee, it has been received. And except too, for their 3 quality of service level, which I'll get into details, that one not necessarily needing the acknowledge part. So, and over here too, this is just an example. I think I already have it also shown a bit earlier. Just an example of you can be publishing data such as temperature from a temperature sensor. You publish the temperature, you send it to the broker, whoever is interested in it, because it's basically marked, as a topic, so that your client, whoever is interested in it, the subscriber or the consumer, will have to subscribe to it. And when the data arrives, then it will be published to them accordingly. So, okay, so that's get deep, level deep too, is to look at these packets, right? So this is a simple example of making a connect, right? So on the packet level, as you can see, connect, you can have client ID. Well, actually, you do need the client ID in this case. And then there are different fields such as clean session. Is it a clean session? Username, password, and then there's this interesting kind of concept too of a last will. So the last will I will talk in the next slide. That you specify your topic, what is the QoS level for this particular client, and then the message itself, the actual payload, this message, and is it a retained message, and how long to keep this alive. And then as such too, if this gets delivered properly, and the broker over here, the broker should then send back an acknowledgement, and it should contain session present, is it the session is present, and it gives you back a return code. So this is a very basic kind of thing. So now, and we'll take a look then into the last will the LWT, the last will testament. Yeah. So okay. So the broker essentially too, this last will, think of it kind of more like people. So last will is more like it's basically the client decides whether it has a last will or not. And so essentially too, it means that if I die, then this would be the message I want to send out, kind of like that. So and it's basically taken care of by the broker. So and if the client really dies, then basically anybody subscribing to this topic will get this message, and the broker will take care of things for you. And it is a real kind of a push message, because it will happen only when the client dies. And it's basically useful to implement like on and off mechanism in a safe way. And yeah, so let's kind of take a look. So over here too, when we take a look into the packet, right? This packet too, if you see, if the last will, it's being turned on this this particular feature, then you see that last will topic will have specified the topic to be using, and then also the QoS level, in this case is a 2, and then the message, whatever it is, and then keep alive. So again, it will be delivered when the client, only if the client dies, and the broker will take care of things for you. Okay, so this one too, actually, I already talked about it, so I won't go into a lot more detail, but over here, as you can see, a publish packet, right, will include the packet ID, the topic name, and then also the QoS level, the retain flag, whether you want to retain the message or not. Essentially, I'll get into the next slide to talk about retain message. And the payload in this case will be, is a temperature. It's just some small data. It can be up to, I think, 256 bytes in here. And then is it a duplicate flag on and off like that? Is you can control, essentially a client can control that. And so now on the subscribing side, then what I subscribe to, you have to, basically have the packet ID and then the quality of service level that it is. And you can have actually multiple subscription to multiple topics as well in this particular example. And by the way, too, the multiple subscription to topic too is that you have flexibility of specifying the quality of service individually for each topic in this particular case. So, okay, so now then we talked about retained message. So what is retained message? So essentially it is the last known like good value, right? So basically too, you can have, you deliver the last message and basically the client will kind of indicate, do I want this message to be retained? So essentially what this means is that I'm telling the broker that, okay, after the last delivery, I want to have this message be retained, be stored. So then new clients that subscribe to this message, anytime it comes like that, then basically the broker will deliver to it too. And that's what this retained message is, right? In a kind of nutshell, you know, as the name implies. So things, for example, like sometimes this is useful. The situation is that if you have new clients coming in, you basically don't have to worry so much about the start state in a sense, because then if there are previous client connection that happens that subscribe to this topic, new client that comes in already automatically will be getting the state kind of like quickly, the data of that particular state right away. So it kind of helps speed things up. And that's kind of like the main purpose for it too. And that's the essentially. And again, it's being managed by the broker too. And it's indicated by the client that, okay, I want this retained. So then it gets delivered when the next client comes kind of get connected to this topic or subscribe to this topic. So. Okay, so now then let's take a look into the quality of services, which is a very key feature of MQTT. There are essentially 3 levels. One, the first one is QoS level 0. It means at most once delivery. And then there's also QoS 1, and it's at least once delivery. And QoS 2 is actually the most kind of guaranteeing kind of guarantee is its delivery to. This one is the most, like, how can I say, most guarantee one level. It actually also means that exactly once, you only want it delivered once and no more, no less. So let's kind of dig into each one of them. So looking at the packet, right, quality of service for 0, as you can see over here, is indicated by the QoS level of 0. And over here too, basically, think of it like fire and forget. So your client, I'm just interested in publishing. I actually don't need any acknowledgement. So then the broker itself too, it just receive it or not, I don't really care in some ways, in that sense, right? So in some cases too, where this might be useful for QoS, is that you maybe don't worry so much. Maybe you're doing some sort of like readings from an instrument and you're doing some cumulative kind of, results from some sensor reading. And you don't really worry so much about missing some data, to be reported from this sensor. Then you can be using that. So the advantage of having this level is that it's quicker because there's no need to kind of like make sure that it gets received and there's no need for you to wait for the acknowledgement in this case. So it's really the quickest and it's only probably applicable for cases in which you are less concerned with the reliability of the message delivery side. Now, getting into the next level, which is quality of services 1, in this case is that we require an acknowledgement. So as you can see, publish QoS level 1, and you'll be expecting the broker to come back if it receives it with an ACK, right, or an acknowledgement. So in this packet, as you can see, QoS is 1, and then you should be hearing back from the broker a packet that's pub ACK and the packet ID that it has. Now, the thing is, I actually did not point out, I think actually, let me go back over here. The packet ID for 0 will be 0 because in some ways too, we don't really worry about receiving anything. So this one, going back here, is that for 1, you do need to make sure that the pub ACK carries with it the same packet ID that you have sent to kind of guarantee that it has been delivered. So. Okay, so now is QoS 2. Now this level is the one that is most more kind of guaranteeing. The reason is that it's like a handshake, right? As you can see too, there are exchanges of messages, like 2 pairs of kind of essentially message exchange. So first is that if you look into the publish packet itself, you see that the QoS will be indicated by 2 in here. And essentially too, once you publish, the client publish, the broker will send back a pub rec. Essentially, it's just kind of like recording in some sense, right? Recording it. I got the packet ID. But at the same time too, then I actually, me as a client, I will actually send back another kind of almost like a handshake, right? I'll kind of like return and let you know that I received that acknowledgement. So it's a bit more like redundant, so to speak. But the thing is, though, it guarantees that, there's only once kind of delivery in this case. And then so once you send the pub rel in this case, then the pub comp is essentially published, like completed, will be sent back by the MQTT broker to indicate that, okay, I got your acknowledgement of acknowledging my first return to you, kind of like that. So as you can see, this particular level is most secure, most guarantee, this case. Now, the thing is too, let me also, I'm sorry if I'm kind of going back a little bit, because I realized what I did not mention about quality of service one, it actually means that at least once. So basically too, you want to use QoS 1 if you don't care about the messages get delivered more than once. You can get duplicate messages too. So in those cases, then you can actually use quality of service 1. It's faster, but you may get duplicates, but you don't really care. But for QoS 2, I only want one because I don't want additional data, which may kind of mess up my whole thing if I'm doing certain kind of operations. I can't afford to have duplicated data type of thing. So that would be kind of the differences between the two. But quality of services, as you can see for 2, will take a bit longer because of the handshake, the extra step of that, additional kind of exchange handshake to kind of guarantee that, both sides have received what they're expecting to receive. So, all right. Okay, so now that was the 3.1.1, what it is about, in a nutshell, really fast, we went over. Then you might be thinking, well, I heard of MQTT 5, but before that, where's MQTT 4? So this is a bit of a trivial information for you, especially for the inquisitive mind. So just wanted to take a look, right? Looking at the packet, right? This is a connect packet. So as you can see, there's a field called version. So in MQTT 3.1.1, the version has been upped to 4. Now, the previous MQTT 3.1 actually version is 3. So now 3.1.1 is 4. Then naturally, too, when MQTT, the next generation, which we now call MQTT 5 or since 2018, the version actually became 5. So I think then they are kind of aligning it with that. And so basically MQTT 3.1.1 maybe should have been called MQTT 4, but it's named 3.1.1. But the version that comes out will be like 5 for MQTT 5 and therefore 3.1.1 is 4. Okay, so that was just a bit of trivial. It doesn't affect how things operate. So now let's kind of get into MQTT 5. Okay, so a quick overview. It is MQTT 5. Again, earlier I mentioned about this being a more robust, kind of versioning of this protocol. It's a successor of MQTT 3.1.1, and it has like non-backward compatible. But the thing is too, if you use MQTT 5, you essentially get all of it that's in 3.1.1. And the nice thing about, say, with HiveMQ is that you can actually be running MQTT 3.1.1 client as well as MQTT 5 client against the same broker too. So that's kind of a bit of a plus too with our broker. Okay, so now quick thing is that it was first released in January of 2018, and the official release, really GA, was like March of 2019. So it's a relatively new protocol, and it's basically catered more for the cloud native world that we live in now, allowing for better scalability, kind of like that robustness side, essentially. So many new features, and it clarifies a lot of the 3.1.1 specification. So over here too, the goals of such too is to enhancements for scalability, which I just talked about, for large scale systems, improved error reporting, formalized common patterns, including capability discovery, request response pattern too, which is slightly different than the typical request response pattern, but we'll discuss in a minute. So, and there are also like extensibility mechanisms like user properties and a lot more like performance improvements and support for small clients too. So some of the new features, right? I won't talk about all of it, but just to give you an idea. So for example, this session expiry is basically an optional part of the connect message. And it's basically a session expiry interval in seconds. So as you can see too, is that it gives a lot more control on the client side too. So, And the broker expires session after the given interval as soon as the client disconnects too. So it gives you a bit of a finer level of control over this expiration aspect for the messages. So. And again, this is actually an optional part of a publish message too, and it applies to online and queued messages. So, and user properties. So this actually essentially gives your application or the programmers to have more control over the metadata headers. So it can be part of most of the MQTT packets, like the connection, the con, pub, and sub too. And basically, it has UTF-8 encoded strings. And you can add as many user properties as you like, as you need as well. So that's user properties. Again, it's all optional. And then this other feature too, I want to point out is shared subscription. So this special syntax up here, as you can see, you use the share and then the $share and ID, and then your hierarchy. That's how you specify your topic, is a special syntax. And it's basically very useful for scaling out the backend subscribers and help with like multiple clients share the same subscription. So as you can see, this type of design is actually really works very well in the cloud native, in a clustering, low balance type of scenario too. And it's basically from HiveMQ's perspective too, it's supported. It's actually, I wanted to point out is that HiveMQ already has shared subscription in the HiveMQ 4, where in which we have support for MQTT 3.1. So in other words, this feature is already in MQTT in HiveMQ before MQTT 5 came out. And I should kind of say it like that. So it's already a very advanced features. It allows for upscaling and downscaling of your clients at runtime. This is really, again, perfect for cloud native scenarios. So this is actually a pretty cool feature. And again, not all vendors are supporting it yet too, but HiveMQ does. You support this fully. So. And this is just a picture to kind of describe what I was talking about, right? So you have your broker publishing to it, but then from the subscription side is that you can have like share subscription by multiple clients sharing the same subscription to the same topic. And again, this is kind of good for like in a Kubernetes cluster, things like that, that you can kind of make use of this particular feature. So. Okay, so now move on to the next feature is the request response. Now, the thing is when we talk about request response, we always kind of think of like HTTP, which is very much a stateless protocol and is synchronous and all that. But no, MQTT request response pattern is not the same as the typical HTTP request response pattern. And it's basically, these are like being used, in terms of a concept being used on on the topics level too. And you can have more than one or no subscriber in MQTT. And basically too, your client must subscribe to a response topic and before sending the data to. So this is actually quite an interesting kind of pattern in this case too. So over here too, I was talking about, oops, I'm sorry. I think I kind of accidentally pressed the button. So basically request response information place for the response topic. And then there's also like correlation data header for the correlation of the request and its response. So that's where I think the strength is that you can actually kind of build, because as such, right, a pub-sub is very much an asynchronous type of protocol. And basically there wouldn't be any like correlation between the request and your response. But the thing is with this request response feature is that it allows you to actually have this correlation data kind of placed in the header to kind of associate your request and its response too. So that's kind of like the one of the idea of having this pattern. So as you can see here in this particular case, you see you publish to the broker, and basically the applicant, any kind of client wants to subscribe to it, subscribe to this topic. And it's basically if when you receive it, then you will be sending back, there's a return message that actually will indicate that's the topic that is associated with in this response like that. So these things are kind of, you kind of making a bit more like correlation between your different clients as such, right? Well, what it is, what topic is it kind of related to, kind of like that. So, okay. So again, this is like a optional features that you don't need to be using all the time. So, okay. So we'll kind of come to this point in which then I would kind of finish talking about the highlighting, MQTT 5 features. And let me then also give you a bit more information too. So basically MQTT overall, right, is very lightweight and very bandwidth efficient. And as you can see, right, the control packet, right, of the MQTT basically is consisted of the fixed header and the variable header and the payload itself. And I wanted to point out it's extremely fast because it's very lightweight. As you can see, the fixed header, which is required, it's actually only 2 bytes, and 2 bytes, I should say. And then basically your variable header, you don't have to have it too, because if you don't need it, you don't have to have it, but you can have it up to like 12 bytes. So as you can see, it's really small. So it kind of like helps with the delivery. You don't have too much like overhead in that case. So. And also too, with MQTT, on the data side too, it's very data agnostic. It supports all kinds of data like images, text in any encoding format, any encrypted data too, and essentially too like binary data too. So it's very flexible. And there's also this particular feature is about continuous session awareness. So it supports like statefulness, right? You want to persist all your data because in any kind of asynchronous type of communication, there's always something challenging is that, what if you lose the connection, you lose the data and all of these, but don't worry, because the broker would take care of things for you. It's like, again, the post office that store messages when you're offline, and all of these QoS level retained messages, all of these things, last will, testament, this kind of helps to guarantee your delivery that your messages won't be lost too. And it's therefore very useful in IoT, especially over unreliable networks, right? You lose your connection and you may lose your messages, but no, again, fear not, the broker is there to kind of assist you. Okay, so now let's kind of talk quickly then about use cases for MQTT. So first and foremost, it's for Internet of Things, IoT. We all are aware of that now. And of course, too, there's also industrial level IIoT as well. And there's also the Industry 4.0 kind of on that conceptual level, and all of the products that are kind of, or systems that are Industry 4.0 kind of level of applications too. So Industry 4.0, just a quick note, is essentially a new kind of a terminology that comes out that indicates, in today's world, when we're using certain systems, it's not only like implementing, like using one kind of technique. It's essentially we're using multiple kind of techniques and frameworks and all these things and make things work together. There's a lot of like interoperability that's involved. We're dealing with different types of data that pass through like different systems. So therefore, MQTT is actually very nice because the PubSub type of kind of mechanism allows you to essentially build out different kind of like pipelines within your whole data flow within the whole ecosystem. So, so essentially too, MQTT is perfect for an Industry 4.0 type of kind of applications. Okay, so in terms of industry verticals, right? Again, I mentioned earlier too, is about like connected cars and things like that. So for example, like automotive industry heavily makes use of MQTT. And logistics company, right? You can have shipping company, things of that nature. Manufacturing, factory floors and automation, all of these small sensors and devices to make sure, your factory, all of these automation is operating, as expected. Energy field like oil and gas. And again, it's not limited to these four, but I'm highlighting these four industries because they really are very good candidates, and already they're customers using these products that are MQTT based. And on the consumer level, basically smart home, right? For us, right? For example, I have my dishwasher, and then my dishwasher, actually I install an app, so it tells me, right? And oh, your dishwasher needs to be serviced. You haven't been using it for a few weeks and things like that. So I get that to maybe your home alarm system, your wearables, your lifestyle, everything. So essentially the possibilities are limitless using this protocol. Okay, so now then let's get a bit to, I realize I'm talking too much, so let me hurry a little bit about some of the other alternative protocols to MQTT. So let's say if you don't use MQTT, what what can you use, right? So first and foremost, people would say, well, HTTP can do the job, handling device kind of communication. Yes, of course you can do that. But the thing is, as we all know, HTTP is pretty heavy, right? It's relying on, you're doing a get, doing a put, doing a delete, and update, all of these things. It's just a lot heavier. It's just not ideally, designed for an environment such as IoT. There's a limited constraint type of environment. So we don't normally recommend that. You can do it however way you want, but we really don't recommend that. So, and then there's also protocols such as constrained application protocol in here. This one is interesting too, but the thing is about it is that it's more, it uses UDP, so user datagram protocol. It's fast, extremely fast, but it's less reliable because of the UDP itself too. It's less concerned with, did I get back acknowledgement, things like that, right? So essentially, in a nutshell, that's what it is. But yeah, that's, and it has its specific kind of usages too, so which kind of goes beyond the scope of this discussion. And then there's also AMQP, which is Advanced Messaging Queuing Protocol, which is now also part of the OASIS governing kind of protocol. This one actually came from the banking industry. It was JP Morgan who started this. So more for financial banking kind of industry. It is kind of widely used as well, but I believe that's more kind of ideal, in kind of a financial type of situation protocol. But again, that's kind of another option that you can have. And then there's also this object linking and embedding for process control unified architecture, which is like acronym is OPC UA. This one is actually more prevalent in the manufacturing kind of factory kind of floor, right? And it's essentially, yes, and that came out of more of the factory kind of, kind of digitizing kind of environment too. So as such too, OPC UA is a bit of a heavier set in some sense. It's actually makes use of like SOAP and that type. And so it is very robust, don't get me wrong, but it has its own specific use. And there are also products these days that actually would have integration with OPC UA, like with MQTT as well. And then there's also, okay, the next thing is data distribution service and DDS, and that's as such, right? It indicates it's more for good for if you have a lot of data, like IoT kind of data. I think this might be also a good alternative for doing like IoT type of communication. And then the last but not least, here on this list, there are some other protocols too, is XMPP. So this one is extensible messaging and presence protocol. As such, it's actually XML based, and it's also very fast, and it's more ideal for instant messaging type of application scenario. Now, again, these, I would say they all have its own strength, but I think the idea is that we want to make sure that we're using the right tools for the right job. But MQTT is kind of superior in that sense because it's so lightweight and it's so easy. And it can be plugged into any kind of environment. So it has really becoming like the de facto standard for doing IoT. You can plug things along the way. You always hear of the word MQTT. So, all right. So again, I brought up to a bit of the integration with other frameworks. So I wanted to kind of point out, for example, you may be asking, Apache Kafka is streaming. Yes, of course, you can use MQTT with Apache Kafka too. We actually do have, HiveMQ has integration too with Kafka. So the ideal scenario, as I'm thinking too, I'm also as such learning about this, is that in kind of and a good application kind of scenario, you could be using MQTT for your edge devices, and you gather all the data, and it's basically then you can leverage then of Kafka to help with all of your enterprise type of operations behind, in the back end kind of thing. So there are actually really good integration. You can have, again, have MQTT, and because of this kind of concept of data flowing through different pipelines, you can gather this. And I believe too, Apache Kafka, I think you can make use of MQTT. There's proxy or some bridge that you can actually bridge and send data that way through from MQTT to Kafka as well. So that's an example. And then there are also other MQTT brokers that actually we can also talk with as well. So think of it more like we're solutioning. We're using different technologies to make your solutions the most robust and most kind of efficient in that sense, right? And then, okay, and then there are also like other runtimes. For example, Spring Boot, if you're a Java developer, Spring also has, well, actually, HiveMQ, we also have support for Spring, and Spring has support for us. So it's kind of interesting, right? You can have different runtimes, and basically, too, MQTT can run on small devices like Raspberry Pi and all these things, and you can be running Spring Boot too. So again, the possibilities are many, but these are just a few examples. So, and in summary, before I start the demo, I know I'm kind of talking too much, so just want to kind of point out again, the beauty, the strength of MQTT is simplicity. Is PubSub kind of model is kind of basically loosely coupled architecture, asynchronous and very lightweight. It allows you to operate in a constrained environment and operating in a high latency network environment. In environments that are really limited. Fear not. MQTT is there to help you out. So it's an ideal protocol for IoT use cases. So. All right, so now it comes to my demo time.
So Mary, so this is Ian. So I think we're running a bit behind here. So we only have 15 minutes left, and we usually like to try and make sure we have lots of time for questions. So so maybe kind of, I know you're doing a Twitch session later on today, so maybe you could at the end you could kind of get a link and put a link in the chat of your Twitch session, and people could kind of see the demo if they're interested in your Twitch session. Does that sound okay?
Yeah, actually, that sounds very good. So folks, please join me on my Twitch session. We can have discussion too. Yeah, I'll be doing a lot of demos there today. So yeah, great.
Okay. So I'm going to start kind of reading some of the questions that we have. Actually, let's go to the resources slide, because I think this is a kind of, let's kind of end with this. Can you just kind of go through this?
Sure. Yeah, let me kind of go through. I guess I won't click on it, but the thing, I believe our slides will be made available to everybody, right? And on the slides there, you can click on this too. And these are just some of the resources that you can get. And they came from, HiveMQ. We have how do you get started with MQTT? And the MQTT Essential series and is a must-have. And I learned so much just by reading through all of the stuff. It's very detailed. And then MQTT at Oasis too. There are also tons of information in there if you're interested in more from the specifications point of view, right? And then there's also HiveMQ broker. If you want to evaluate their free tier kind of usages, you can download it, and you can actually just quickly spin up, using Docker to bring in your MQTT server like broker locally as well. But that I will illustrate this afternoon. So please kind of consider joining my session this afternoon. And then if you are interested to, please try out our HiveMQ Cloud. We have a free tier access. You can quickly spin up a cluster in no time, essentially. So yeah, so those are the things that you can have. And now we have a question, Q&A time.
So I'll read off some of the questions here, and we can kind of go through them together. So is there a graphical way to view the broker's connections to PubSub clients and monitor in real time? And just we're also putting a poll up for people to just be great if you can kind of submit your responses to. There's just 3 quick questions, just so we can understand who attended and kind of what your experience like was. So a graphical way to view the broker's connections to PubSub clients and monitor in real time. So I think that would be so there's a number of suggestions I can make. There's kind of HiveMQ has what we call the HiveMQ Control Center that allows you to monitor your broker clusters, but also the clients and message throughput that goes in through it. There's also some utilities, MQTFX would be able to as a utility that you could use for that too, to be able to do that. So those are kind of 2 suggestions I would have. Mary, can I use MQTT if I need a timestamp for the date for the hello, can I use MQTT if I need a timestamp for the data?
Oh yes, actually you can, right? You can actually use timestamp. You can use anything for. You're talking about the payload, right? Yeah, you can have any kind of data in there too. I believe so, right? Yeah.
Yes. So you'd add the timestamp. You as part of when you create the message, you'd add a timestamp for each message.
Yeah, that's right. Is that the question? I'm trying to understand the question.
Yeah, I think that was the general gist of the question. How would you get a timestamp into the message? So.
Oh, how do we get a timestamp from the messages is what you're asking. Oh yeah, that's right. Okay, I'm sorry, misunderstood. I think by default, I'm not sure. I think if you can be able to actually have some system call to get your time, and then basically I think by default you may not have the timestamp. You probably have to
added in.
Yeah. That would let me kind of take a look. Again, I'm relatively new, so some of these details, let me look into that. But you can also add your timestamp into a payload, but obviously you want to try to see if the packet itself already has timestamp like by default, right? I think that might be the answer. But yeah, let me go find that out for you. And basically, I'll answer your questions. I have the answers ready for you in my Twitch stream this afternoon. So.
So there's more coming in here. Let me just.
Sure.
Sorry. There's one that I've lost. Okay. Are you aware of any surveys statistics comparing the popularity of MQTT with other protocols? Yeah, so I know the Eclipse Foundation does an annual IoT developer surveys where they ask what protocols they're using. If you Google on Eclipse IoT developer survey, you'll get kind of their latest, and they've been doing it for a number of years. So you can see the trending. Typically in those survey results, you get HTTP and MQTT kind of are the top two, and everything else is a distant second. IoT, HiveMQ actually just recently did one with IIoT World in the manufacturing setting. And I will actually dig up a link to that and put it in with the answer too for that. So there is some out there. Let me just go. Can you elaborate on security? Do you want to take that, Mary? Or do you want me to help with that?
Oh yeah, I think, okay, maybe let me, from what I know, right, MQTT supports SSL and TLS too. And in fact, there's also payload against encryption with that too. But some of the details, I think maybe Ian, you can address it at this point. As such, I'm fairly
yeah. So absolutely, we absolutely encourage people to use TLS when you're transmitting MQ messages. That absolutely works out of the box. You can also do things like access control lists and I think authentication authorization for the client. So HiveMQ actually has a security extension where you can use third-party data based on either OAuth providers or username passwords or certificates that will authenticate clients as they come in and do authorization based on rules for clients. So you can actually scope certain clients to certain topic structures, for instance, for that. So Mary, some of the people are asking, can I put details of the evening sessions? I think you have actually put it in into the
oh yes. How can I? Let me quickly type it in here on the chat, right? So okay, I can just type it in here to stream. Yeah. So. Yep, and I'm just typing it here right now.
So there's another question about how do you compare with ZeroMQ? So I'm not overly familiar with ZeroMQ, but Mary, I'm not sure if you've got any experience. Like I guess for me, MQTT is a standard protocol that's implemented in many different kind of brokers, right? So HiveMQ has a broker. There's Mosquito, but AWS IoT, Azure IoT, all implement MQTT, right? So it's pretty well a wide standard. My understanding, I might be wrong on this, so please don't kind of flame me on this, but ZeroMQ is an implementation of a broker with its own protocol. And so we've never really done a comparison with ZeroMQ and MQTT or HiveMQ. So I apologize about that. So what else do we have here? Is there an alternative to Noved to develop MQTT applications? Well, it's Mary, maybe you could talk a bit about kind of what you're going to show in your demo, even though you didn't have time to do your demo. So kind of how would you go about developing an MQTT application?
Oh, sure. Yeah. So really quickly, right? Yeah, I was going to show is this can be like as quickly as well. You bring up your broker and basically you can have client that essentially have, make a connection, right, to your broker. And from there, you can then basically subscribe. You can right away and say, like, subscribe to that topic. And then you can have another client that essentially publish to that to that topic right away. So it can be as quickly as that. Of course, it requires some steps of setting up, but other than that, once you get things set up, I was going to just quickly show a Node, a JavaScript client too. So all you need to do is basically spin up your broker and then making an MQTT connect, like a connect, and basically do an MQTT to that to the endpoint. And then from the endpoint, then you can then do a client.subscribe to the topic. And basically the topic will get created when you subscribe to it. And then when you then you can publish to it. So it's pretty dynamic. There's no other setup, and which I found to be what a delight, it's like very delightful. I should say that, because it's more like, yeah, you just do a subscribe. The topic will automatically be created for you if it isn't already there. So like that, and then you can then publish, and then you get the messages. But now one caveat is that be careful, right? With any kind of pops up asynchronous type of processing, it's not, if you look at the code, it does things like one step at a time like that. But because of the timing, we don't, kind of the timing is the key, right? And pops up thing. Then if you do a subscribe, the data isn't there yet. And basically you don't know when, because then it's up to the publisher. When it publishes, then the data will be there, and the broker will deliver also at a different time. So the thing is, to an illustration I wanted to do in my particular example is also show you writing a small little timer that will delay the closing of your client. So then so that the client doesn't die before it gets published, like that, right? So anyway, to kind of summarize, it is as simple as do a connect, subscribe, and publish. So I hope that helps.
Yeah, but you're writing in code, right? So you could actually write a Java application, right? You could write a Python application, you could write a JavaScript application, right? In a text editor, you're writing code, you use an MQTT client to formulate your messages. And there's many different MQTT clients out there. Eclipse Paho is probably the source of most MQTT clients. HiveMQ has a Java client that many of our customers will use. So there's Node-RED is perfectly good for getting going on MQTT. Like I think what Nick O'Leary has accomplished with Node-RED is amazing, right? So I don't want to take it away from him, but there's lots of different ways you can get going. I actually just posted in the chat a link to our Getting Started article, which would go through the details of how you could get going. So let me just see. Yeah, I think we've got a lot of other questions that we're just not going to get to. So I think we'll call it a day there. So I think a couple of suggestions I would have, if you do have questions that you want to follow up on, please go to our community forum. So community.hivemq.com. I'll just put a link into the chat. Feel free to ask your questions there, and we'll absolutely, our support team will absolutely try and get to you. And Mary maybe will be following that too, so we can to get to those. So please join us there. Mary's Twitch stream is there. Like I said, we offer a lot of resources on our website, MQTT Essentials. We have a free trial of HiveMQ you can download with a tutorial on how to get started. And we also have HiveMQ Cloud. So if you don't want to actually run the broker yourself and just connect to our managed service, we offer that too. So we provide lots of ways to get going. We also do these webinars once a month. So keep your eyes open for our next webinar. Mary, any final words that you might have?
Not at this time, but I like to get folks excited. Let's join me on my Twitch. We'll be setting up more things too. I think as things kind of get set up, and as me get settled down too. So yeah. But this has been a wonderful opportunity to be talking about MQTT. I'm really excited about it now. All the possibilities you can do with it too. So yeah. So thank you.
It was a great session, Mary. Thank you very much for doing it. And thank you everyone for the great questions. Sorry, we won't be able to get to all of them. But thank you for the engagement, and we'll definitely do something like this again. Thank you. Take care. Bye-bye.
Thank you. Bye-bye. Bye.